James, right?
Yes.
Bob Hanlon.
Pleasure to meet you.
Pleasure to meet you. Welcome to Corning. The goal here is to learn by practice. So I'm going to be behind the scenes, observing, guiding, giving you feedback constantly.
The practice school is a unique program that we have had running at MIT now for the last 100 years, looking at both the technical, the fundamental aspects of the chemical engineering profession, and all of these in the context of working within a company setting.
Know that by the end of your project, you want to be telling the company what you think they should be doing, the results of your efforts. You got to move. You want to strive for impact.
What the practice school helps with is experience, and it also teaches them the value of drive. You don't live through practice school without a lot of drive.
So tomorrow is a coat and tie day. That sets the tone right off the bat.
It was great. We had people from all over the world. There was a kid from Greece, there was a kid from India, there was a kid from the Philippines, there was kids from everywhere.
Hi there. Daniel. I hope to gain a lot of experience, how it is to be an engineer, not in a research setting, but in the setting of an industrial project.
You all should just be sponges, right? You should practice. If you're not good at something, go figure out how to volunteer for it. Try things. Try things in those first few years. And oftentimes I would find things that I'm uncomfortable with and I would do them more. Because typically when you're uncomfortable with something is what you're not good at.
We're really interested in establishing this problem-solving ability in a real setting, bringing the human dimension into it, and trying to get something done in a relatively short period of time.
Scientists turn dollars into ideas, and engineers turn ideas into dollars.
I want to be part of a productive working environment. I want to be in, the everyday life of a chemical engineer and be like, okay, so we have to go to the plant. The operators are having these issues. How do we fix them?
It's a very intense experience.
You're big.
It's a very rewarding experience. And honestly, I've never worked so hard in my life.
Daniel, you're going to be the group leader on the first project with Jimmy and Ina.
Wait, did you already change the password?
The students are required to sort of develop their own approach to solving problems, to take the initiative, to learn how to really think about the problems critically.
It doesn't really say what the problem is, does it? Or do you understand what the problem is?
In the patent? No.
Or like in the problem statement anyway?
Leaching, yeah, which is very vague.
The problems that they get here in industry are not well-defined problems like you find in the classroom or in the textbook. They're very open-ended problems, and part of the project for the students is how do you even define the problem that you're working on, which is a great experience for them, however frustrating that may be.
The lag phase is at least 24 hours.
You have to really dig into the company history. What have they tried before? What do they currently do? How do they currently run their production facilities, lab techniques? And to be fair, learning in 1 week what a company's done for years can be very challenging.
The goal of this morning is for the sponsor of each project to present, here's what we're up to with the project, here's how we see, the practice school station team approaching the project. The projects that Corning gives us are very real projects. Corning gives us things that they're actively involved with right now, and they actively want an answer to it.
The area is for single-use technologies in bioprocess. And there's a few issues with the current technologies that we're hoping to solve with the support of MIT.
You would first get the project assignment, and it was more or less sheer terror until it was done.
We have been dealing with this issue for around 6+ months, so we are really looking forward for some fresh inputs and ideas that can enable this to move forward and us to gain more mechanistic understanding of what's going on.
A lot is going to be expected of you in a short period of time, and the pursuit of excellence on a project is the total expectation, not just finishing a report.
The big challenge that we would like your help with is adapting the etch process to etch out these really small holes.
Don't underestimate what these students are capable of in a 4-week program.
Before we knew it, we had to give a first presentation, and the whole thing was pretty hectic, and it was pretty much like a controlled train wreck.
Today is the day where the students give their project proposals. What they're going to be doing is presenting what their understanding of the problem is they're working on, and what their objective is in addressing that problem.
Basically, if you think of these as small individual disposable bioreactors, that's what they are. You have the tubing in here to regulate conditions, pump in your feedstock and everything. So feel free to take a look at this during the presentation.
The biggest challenges for us will probably be planning the correct experiments we can do in the right amount of time to maximize our output.
Our project is quite lab intensive, so we're using some very hazardous materials to run experiments and validate the theoretical process that's been proposed for this mechanism.
In the real world, information is incomplete, and you gather as much as you can, you run the set of analyses and experiments that you think will generate the most useful information, and then you have to decide.
I have a great team behind me. We're all working together to solve this problem, so even though I may not have the expertise, I know that I can bounce ideas off my teammates and that together we can get this done.
Good morning, everybody.
Good morning.
So yeah, there was a lot of discussion right on Friday with your project about what are you going to measure. There were feedback from different people.
Working with Bob has helped a lot. He really made us critique and analyze how we present ourselves.
If you had to do it over again, would you have done anything differently?
I think communication.
In what way?
Communicate earlier and more directly with both parties. And even people within our group, within the SP group, not all of them knew exactly what was going on, and everybody wanted to know. Everybody wanted to be updated with all the facts, with all the experiments right away.
It's not all about technology and knowledge and science. It's a lot about dealing with people.
Have you ever heard of the philosophy, one data point is worth 1,000 opinions? So what does that mean when I say that?
You can say what you want, but if you don't have proof for it, it doesn't really mean much.
Yeah.
I can't let myself be scared of the problem, because if I think too much about all the things that I have to do, then I will get too overwhelmed and I won't be able to function.
We had immovable deadlines and very intense pace. We also had the urgent requirement to develop good team skills, because it was impossible to succeed in a practical project without teamwork.
For this particular project, I feel like I'm lacking in technical knowledge and technical capability, because it is so chemistry heavy and it relies on a lot of knowledge of flasks. How do they expect me, someone who is completely new to this area, to really contribute in a meaningful way? I'm not really sure what contribution I can make, and that concerns me a little bit.
Corning gave us these projects exactly because of that, because they're wrestling with really trying to understand some of the fundamental chemistry and physics involved. So they say, well, let's bring on a fresh set of eyes and see what happens. That's you.
Yeah, and I think that's, seems like that's why we're here. They want a fresh pair of eyes.
A fresh pair of intelligent eyes, which is what you all bring.
Of course, that's definitely useful. I just don't think we should... This experience is really real. I feel they really throw us into situations where they want to make money with this product. So we have to find a way to just add value fast.
Just grab the door too. Oh boy. No, this is all good stuff. This is all good stuff.
In the practice school, you have the opportunity to be challenged a lot with what you're talking about and to defend yourself and to take criticism about how you did things.
You got a final presentation in 2 weeks.
Yeah.
Okay, so what did you learn from your first presentation?
I was talking very fast.
Okay.
My communication was not as effective as it should have been. Glass is a desirable alternative to silicone for electrical interposers. What is an electrical interposer? Well, let's look at this image right here. An interposer is this piece right there.
Well, so what the feedback was what?
Well, I was speaking too fast.
Right.
And it felt like I was nervous. And I need to work on that. That goes back to the demeanor that I want to try to transmit. There was clearly a deficiency in their communication, because we both had said things, or we were certain we had said those things, but then they didn't get to the audience. I mean, that is a problem, because if the audience doesn't get it, that's the whole point.
There's a reason why this is the practice school, right? I mean, you're practicing, doing this type of stuff, and this is high-level stuff, and you're speaking to a room of experts who really know this stuff.
Things never go the way you expected them to, and so the equipment didn't get built as quickly as it should. And the first data that we collected made no sense whatsoever. And we're getting behinder and behinder. And so now we got to start working in shifts and working long days. And this is when the teamwork aspect gets difficult.
Let me get the hair right.
Okay. Tell me when your hair's ready. I know I didn't bring my makeup team with me today. It sounds like you guys hit a snag the other day.
Yeah, we did. We were trying to develop a theoretical model to explain what we had found a little bit better and give some nice chemical engineering fundamentals to go with what we were doing. And we had made some calculations and they seemed to correspond very well with our results. But then yesterday during the night we realized that there was a pretty important mistake in what we had done.
Carlos tells me that there is a typo in one of the diffusivity constants that we collected, and therefore we had a four orders of magnitude error in our prediction. Which, of course, 4 orders of magnitude is huge, is very big.
The things that seemed as if they fit really well with what we wanted didn't fit anymore. So we had to stay a little bit late trying to figure out how to fix it. We had to remove some of the simplifications we had done.
It's Tuesday morning, so we were less than 48 hours away from our final presentation, and essentially we had no result, or we had no result that made sense.
It was a little bit overwhelming. Ooh, how are we going to fix this? Do we have enough time to fix this? You know, we have to think about this. And we stayed until pretty late. Trying to finish as much as possible, so there's a little bit less sleep than we would have liked.
Next, once we have 2 of these chromatograms that we deem similar enough to compare, we can look at each peak and see whether there's another peak that's close to it and see whether it has a peak that matches up in another bag. If it doesn't, then it's identified as a unique peak.
Yeah, sorry to, I guess, be overly critical. I worry about the time because we've gotta. I don't think we can cut anything because I think all of it's important and all of the stuff we did. So we've got to be concise with what we say.
When you get into this, you're going to start losing people. I'm just saying. I mean, this is going to get complicated fast. The question is, how do you unfold the story in a way that works? You're going to have people getting confused if you're not consistent.
Yeah, I know.
We really had to take it from the ground up. We had to start with kind of a very limited amount of company expertise and really search outside the company, search in the literature, look what else had been done. Help Corning to adopt a business strategy.
And by the end, they know how to get things done. They know how to do work. They know how to be productive. It is the drive to understand, the drive to have impact, the drive to be curious about why something works or something doesn't that really helps people be successful in industry.
The major advantage of using the iris laser is that it can be significantly faster. We went to the lab and we changed some of the experimental conditions to see if we could obtain evidence that indicated that by manipulating the transport conditions, we could affect the final product. And we obtained some interesting results.
All answers have a degree of uncertainty, and there's risk to anything you might say. So if you want to propose, say, a change in the plant, you're going to have to convince a lot of people that this is a good idea and that it will lead to some value, whether it's improved yield or profits or better understanding.
If you study the conservation of mass along this cylinder, you can understand that there are fluxes that are interplaying with each other. You have diffusion going in this direction and a reaction that is consuming it.
We promised our big customer to have this technology in 6 months, and it seems like we proved that it is possible much faster, and thank you for that work. I really appreciate that.
When we presented our final results and they saw that we actually achieved what they asked for, other people higher up in the company came to us and congratulated us and wanted to chat about it.
We were able to get the work actually patented. That really has stuck with me, you know, it's that feeling of we did something that had value for the company.
Corning's ultimate strategy is to gain a foothold in this market. So the question is, now that we have a list of mechanisms by which these antioxidants can break down, which ones of these are present in the extractables and leachables? The answer is every single one of them.
That was my only industrial experience in my entire career. I had an academic career, and what I learned from that industrial experience was immensely valuable in giving me a feel for how to communicate things to industry, what would be of interest to industry, and how to ground my research onto something practical.
The question is, how fast is that reaction relative to the overall timescale of the experiments?
You learned a lot about yourself. You learned a lot about life.
So, if Corning came to me and offered me a job, I wouldn't mind. I actually had a great time in Corning. I thought Western New York was beautiful.
People say it's really, really hard work. And it is. But boy, it's fun.
I think you did a good job yesterday.
Good job, Jamie. Good job.
I know, right? It's actually fun.